Hi, future scientists. I'm Atom. Today, let us discuss what covalent compounds are, the differences between single, double, and triple covalent bonds, 5 naming tips for binary covalent compounds, 3 common mistakes to avoid, and 10 practice questions. So, what are covalent compounds? Covalent bonds are formed between the atoms of nonmetals. Nonmetals are to the right of the metalloid stairway in the periodic table, plus hydrogen, which is located on the left side of the periodic table. Covalent bond involves the sharing of one or more pairs of electrons between the nonmetallic atoms to complete their outer electron shells, thus forming a stable or happy molecule. It is like one student has a pizza and the other has a pretzel. They share, so now both can enjoy the pizza and the pretzel. Or one student has a science book and the other a math book. They share the books, and now both can study science and math. Compounds containing covalent bonds are called covalent or molecular compounds. Single, double, and triple covalent bonds. The compound HF. Hydrogen has 1 valence electron and fluorine has 7 valence electrons. So a pair of electrons are shared between the hydrogen and fluorine atoms to form a single covalent bond, and both the atoms are happy. H2O. Hydrogen has 1 valence electron, oxygen has 6 valence electrons. So 2 hydrogen atoms will bond with 1 oxygen atom. They share electrons to form 2 separate single bonds. NH3. Nitrogen has 5 valence electrons. Hydrogen has 1 valence electron. So 1 nitrogen is going to bond with 3 hydrogen atoms. And they share electrons to form 3 separate single bonds. CH4. Carbon has 4 valence electrons. Hydrogen has 1 valence electron. So 1 carbon will bond with 4 hydrogens. They share electrons to form 4 separate single bonds. O2. Oxygen has 6 valence electrons. So 2 pairs of electrons will be shared between the 2 oxygen atoms to form a double covalent bond. CO2. Carbon has 4 valence electrons and oxygen has 6 valence electrons. So in CO2, 1 carbon atom shares 2 of its electrons with each of the 2 oxygen atoms. So there is a double bond between the carbon and 1 oxygen atom, and another double bond between the carbon and the second oxygen atom, with the carbon atom in the middle and the oxygen atoms on either side. N2. Nitrogen has 5 valence electrons. So 3 pairs of electrons are shared between the 2 nitrogen atoms to form a triple covalent bond. Naming tips for binary or 2-element covalent compounds. Tip 1. The first element, which is named just as the original element, is the nonmetal further to the left or the bottom of the periodic table. In other words, the element with the lower electronegativity comes first. Example, HCl. Hydrogen has a lower electronegativity than chlorine, so hydrogen comes first. PCl5, phosphorus has a lower electronegativity than chlorine, and you can see that phosphorus is also located to the left of chlorine. So phosphorus comes first. Exception 1. Even though oxygen is positioned to the left of the halogens, oxygen has the second highest electronegativity, next to that of fluorine, which has the highest electronegativity. So oxygen is written as the second element when it bonds with any halogen except fluorine. For example, look at the compound Cl2O. So chlorine has a lower electronegativity than oxygen, so chlorine comes first. OF2, oxygen has a lower electronegativity than fluorine, so oxygen comes first. Exception 2. In NH3, conventionally, H is written second, even though hydrogen's electronegativity, which is 2.2, is lower than that of nitrogen, which is 3.04. In CH4, hydrogen is written second, even though hydrogen's electronegativity of 2.2 is lower than that of carbon, which is 2.55. This is because CH4 is an organic compound, and organic compounds are written starting with carbon. Tip 2. The second element gets the "ide" suffix. If the second element is oxygen, it will become oxide, fluorine will become fluoride, sulfur will become sulfide, phosphorus will become phosphide, nitrogen will become nitride, and so on. Tip 3. Greek prefixes are used to indicate the number of atoms of each element in the compound. The prefix number correlates with the subscript in the element formula. The Greek prefixes are: 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, 10 is deca. It is important to note that if there is only one atom of the first element, mono is not used. Mono becomes silent. CO2 is carbon dioxide, not monocarbon dioxide. NH3, nitrogen trihydride. CCl4, carbon tetrachloride. Tip 4. When the prefix ends with A or O and the second element name starts with an O, which means the second element is oxygen, drop the A or O from the end of the prefix. CO is carbon monoxide, not carbon monoxide. N2O5, dinitrogen pentoxide. It is not dinitrogen pentaoxide. Tip 5. Certain compounds are usually recognized by their common names rather than their systematic names. Like H2O is water, NH3 is ammonia, CH4 is methane. Practice questions. 1. N2O3, dinitrogen trioxide. 2. SCl4, sulfur tetrachloride. 3. IF5, iodine pentafluoride. 4. P2Br4, diphosphorus tetrabromide. 5. N2O4, dinitrogen tetroxide. 6. P2O5, diphosphorus pentoxide. 7. SF6, sulfur hexafluoride. 8. S2F2, disulfur difluoride. 9. H2O, dihydrogen monoxide. 10. P4S5, tetraphosphorus pentasulfide. There you have it. Naming covalent compounds demystified. Please don't forget to like, share, and subscribe for more science content. Happy learning! Thank you.